This is problem 12 of the 2022 MMATHS Individual Round. And the problem reads, let triangle ABC with incenter I satisfy AB equals 10, BC equals 21, and CA equals 17. Points D and E lie on side BC such that BD equals 4, DE equals 6, and EC equals 11. The circumcircles of triangle BIE and CID meet again at point P, and line IP meets the altitude from A to BC at X. Find the quantity dx times dx squared. So first of all, let's draw a diagram to get sort of an idea of what this problem is we're saying. Let's draw a triangle ABC. AB equals 10, BC equals 21, and CA equals 17. So this is A, this is B, and this is C, where the sides are 10, 21, and 17. Points D and E lie on side BC such that BD is 4, so BD is 4. DE is 6, so E is 6, and EC is 11. The circumcircles of triangles BIE, where I is in its incenter, so I should be somewhere right here. The circumcircles of triangles BIE and CID meet again at point P. So let me draw these two circumcircles, circumcircle of BIE and the circumcircle of DIC, which looks something like this. And we get a point P over here. And finally, line IP, which I will do in orange, meets this altitude from A to BC at some point. Like maybe if I drop this altitude about right here. This point is going to be point X. And finally, let me draw dx and EX. I want to find the product of these two squared. And so how we're going to do this problem, we're actually going to do this using coordinates, but we are going to use some synthetic observations to make our lives a lot easier. All right. So let me draw my coordinate axes right about here. And what I would really like is to put my triangle looking like this, in such a way that point A is on the y-axis, points B and C are on the x-axis. But we don't want to give the coordinates of A, B, and C. We would like to find them, and luckily we can, because we know a lot of information about this triangle. This side is 10, this side is 17, and BC is 21, so we can split BC up by the origin O, such that BO is equal to X, and CO is equal to 21 minus X. Finally, we put this height from A to O as H. All right, and now what we can do is we can use the Pythagorean theorem on triangle ABO, and triangle ACO. Pythagorean theorem on triangle ABO states that x squared plus h squared is equal to 100. Pythagorean theorem on triangle ACO tells us that 21 minus x squared plus h squared equals 17 squared to 89. If we subtract the first equation from the second equation, we end up with 21 minus x squared plus h squared minus x squared minus h squared is equal to 289 minus 100, so 189. And the h plus h squared minus h squared cancel out. And we're left with 21 minus x squared equals 189. If we expand out 21 minus x squared, we get x squared minus 42x plus 441 minus x squared equals 189. We can cancel out this x squared term and this x squared term and combine like terms in this equation to get 42x equals 441 minus 189, or 252. Therefore, x equals to 6. So this distance over here is equal to 6. However, since b is to the left of O, we need to make our x coordinate negative 6. So b is at negative 6, 0. C, this distance is 21 minus 6, which is 15. So c is at 15, 0. So if x is 6, finally let's find h. We have that x squared plus h squared is equal to 100. However, since x is 6, we have 6 squared plus h squared equals 100, giving us h squared equals 64. H equals 8. So point A is on the y-axis, 0, 8. All right, that is very helpful because now we have the coordinates for points A, B, and C. Now the next thing we can do is we can find the coordinates of point I, which is another very important point. All right, so I should be somewhere over here. And the incenter is defined as the point in this triangle that is equidistant from each of the three sides. So this length, and this length are all the same. And we can actually find what this length is, and this in radius, as we call it, will be very, very useful. There is a formula that states that the length of the in radius, which we will denote by little r, is equal to the area of the triangle divided by half the perimeter. So perimeter divided by 2. And we actually can find the area and perimeter of this triangle. The area, well, how do we find the area? Area is half base height. The base is 21 here, and your height is 8. So the area is equal to half times 21 times 8, which is 84. Perimeter is equal to 10 plus 21 plus 17, which is 48. So perimeter divided by 2 is 24. So our in radius is equal to 84 over 24, which, if you write this all out, is 3.5. How is the length of the in radius going to help us? Well, now we actually know the y coordinate, or I. And the reason is because I, side BC, is on the x-axis. And so if the in radius is 3.5, that means that this distance is 3.5 here, meaning that the y coordinate of I is 3.5. So let me write this down. I has y coordinate of 3.5, but we don't know the x coordinate, so we'll just call it little a for now, a 3.5. All right. Now, how would we find A? Well, it turns out we can find A by using distance from point to line. And in particular, we are going to find the distance from I to AB, noticing that this distance must be equal to 3.5. 3.5. So how are we going to use that? We're going to use the distance from a point to a line formula. Namely, the formula goes that if you have a point x0, comma y0, and a line ax plus by equals c, then the distance from this point to this line is the absolute value of ax0 plus by0 minus c over square root of a squared plus b squared. And in particular, this line AB, well, it will actually have slope 4 over 3. So the slope is 4 over 3, the y-intercept is 8. You get y equals 4/3 x plus 8. All right? And so we can rewrite this by multiplying both sides by 3 and rearranging. You get 4x minus 3y equals negative 24. So this is our desired form of line AB. And finally, our point is a comma 3.5. So we can plug this into the formula to get the distance from point I to line AB is absolute value of 4a minus 3 times 3.5 plus 24 over 5. Or should I say square root of 3 squared plus 4 squared? And if we simplify this, we get 4a plus 13.5 over 5. And once again, we know that this distance should be equal to 3.5 because the distance from I to every side is 3.5. Okay, now when we solve this equation, 3.5 equals to absolute value of 4 plus 13.5 over 5. We're going to get two solutions. The reason is because this is an absolute value equation. Like if we were to multiply both sides by 5, we get 17.5 equals absolute value of 4a plus 13.5. What would that mean though? It would just mean that the two solutions to this are 4a plus 13.5 equals 17.5 and negative 17.5. This first solution would give you a equals 1. Second solution would give you a equals negative 31 over 4. But which solution do we actually care about? Well, it turns out we care about the a equals 1 solution because the a equals negative 31.4, well, that's your x coordinate, but since I is on the inside of this triangle, the x coordinate can be at the very least negative 6. So negative 31.4 would actually go somewhere like way over here, where this distance is also 3.5. So that's not the point we want. Instead, we want a equals 1. So we can take that as our solution for I. So our in-center is 1 comma 3.5. And this is a huge step in the right direction. Because now that we know where our in-center is, we can deal with some of the rest of these points. In particular, it's time to find some of the lines we are intersecting. Remember, we care about where point X is. And point X is the intersection of line IP and the altitude from A to BC, which very conveniently happens to be the y-axis. So if we can find line IP, we are basically done. However, we don't know where P is. But what we do know is that if D is here, BD is 4, so D is at negative 2, 0. We have point E is here, DE is 6, so E is going to be at 4, 0. And then we draw two circles, which look something like this, and this. They intersect at point P, and we care about IP. But here's another very key synthetic observation. We do not actually need to find P. Because what this line IP basically is, let me draw this in red, it is the radical axis of the two circles. Now, a radical axis of these two circles is basically the set of points which will form a line. And this line will be through the two intersection points. But every point on this line will have the same power with respect to both circles. And what do I mean by that? Well, what I mean is there's this theorem called power of a point theorem that will tell you that if you have a point X in a circle and two intersecting chords, and we're going to call these points M and P and Q. The power of a point tells us that xm times xn equals xp times xq. Right? And we call this quantity xm times xn the power of x. And what does it mean to have the same power with respect to two different circles? Well, all it means is that if you have another circle and you draw another chord that goes through x on that circle, and we're going to call these points u and v, then if x has the same power with respect to both circles, that would mean that xp times xq is equal to xu times xv. And what that means is that it's entirely plausible for us to find some other point on this line IP, because we don't need to know what P is. We just care about this line. And in particular, I would love to find the point where this line intersects the x-axis, because there are a lot of things we can do to find that point. Now, what do I mean when I say that? Well, let's dissect segment BC separately. We can call this point B, this point C, and we can draw our two circles going through B and going through C. So let me draw another circle that goes like this. Now, I is over here, P is over here. We don't care about IP. We don't care about P, actually. We care about this point over here. I'm going to call it point Z because it's important. All right. But what do we know about this point Z? Well, let me label this point D and this point E for good measure. We know that BD is 4, EC is 11, and DE is 6. So why don't I call DZ x and EZ 6 minus x? Diagram not drawn to scale, of course. Since z is on the radical axis of these two circles, we have power of point z with respect to this circle is equal to power of point z with respect to that circle. But what's the power of point z with respect to circle VIE? What's the power of point p with respect to this circle? Well, it is 6 minus x, this length, times 4 plus x, this length. Okay, now what's the power of point z with respect to the other circle, this circle CID? Well, it is equal to this length, x, times this length, 17 minus x. And we can use that to actually find what x is. In particular, we have, if we expand out this left side, we get negative x squared plus 2x plus 24 equals negative x squared plus 17x. Right? And we can cancel out this x squareds, and we get 24 equals 15x. Or we get x equals 24 over 15, which we can write as 1.6. So now going back to our diagram, if x is 1.6, what does that tell us about point z? Well, point z is on the x-axis, so we can find the coordinates of point z. The y-coordinate is 0. If x is 1.6, what that means is that bz is 5.6. But b was at negative 6, 0. So 5.6 would take you to the point negative 4. Negative 0.4, excuse me. So z is at negative 0.4, comma 0. Now, why did we want to find z? Because we wanted to find line IZ. And remember, I was 1, comma 3.5. So why don't we find the equation of this line? It turns out the slope of this line is 5 over 2. So you get y equals 5 over 2x, and then we can write plus 1, because 5 over 2 times 0.4 is negative 1, plus 1 is 0. 5 over 2 times 1 is 2.5, plus 1 is 3.5. So this is our line, and the intersection between this line and the y-axis is the point 0.01. So this diagram is not drawn very well, but if it were drawn a little better, we'd see the intersection would be right about here. So finally, we have x is equal to the point 0.01. But since d was negative 2, comma 0, and e was 4, comma 0, we can actually find lengths dx and ex. And how are we going to find the length of dx and ex? Well, just using a distance formula. The distance between points negative 2, comma 0 and 0, comma 1 is just square root of negative 2 minus 0 squared plus 0 minus 1 squared. That's square root of 5. The distance between e and x, so ex, so e was 4, 0, and x was 0, 1. So that distance is going to be square root of 4 minus 0 squared plus 0 minus 1 squared, which is square root of 17. All right. Finally, dx times ex is this product. So dx times ex equals square root of 5 times square root of 17, square root of 85. So dx times ex squared should give you a final answer of 85. That's it for problem 12. Thanks for watching, and I will see you next time.